Hey guys, before I get started, I just wanted to say thanks for 100,000 subscribers. In honor of that, I wanted to do something heavily requested by you all, which is making an engine upgrade for my car. Now my last engine was an inline 4, which was a good starting point, but now I want to try stepping it up and making a W16. W engines are like V engines on steroids, so I'm just going to jump right into it since it's easier to show than explain. So I start off just by loading the save file of my car, and I give it a quick run here. You can watch the playlist up here if you want to see me making this whole thing, but it's not strictly necessary for watching this video. And the reason I load into this is actually for way in the future. Right now I don't plan on messing with it at all. All I want to do is just have it ready to go so that when I finish the engine, I'm able to just move it on top of this car and I won't have to recreate it later, which would be kind of really annoying. So I just build up far away from the car and give myself a bit of a base to work off of. So after I do that, I want to start working on the crankshaft. Now this is going to be functionally pretty similar to both the one I made for my inline engine and the bomb-powered engine, and for that, I just put a few wooden blocks like this, a couple swivel joints facing into each other between them, and then finally I just have to brace it together with a few bracing pieces. And now as I try to turn it, you can see that the crank stays rigid, but the swivel joints are allowed to move freely. And that's where I'll be attaching the piston to. Now this is where things diverge a little bit. So here I actually put a separate set of swivel joints on top, and I extended the crank up a little bit more. And this is because, well, I was hoping to be able to use this for the VR setup. Now the W engine design I'm going to go with is basically two VR formations themselves in a V formation, so it's a little bit meta here. Now the VR formation is similar to the V engine, where in the V engine you would have two pistons that are at an angle between each other and attached to the same point. In a VR engine, it's a little bit different, and you still have two pistons, but instead of being attached to the same point, they're attached 180 degrees out of phase from each other. So the R, I'm assuming here, stands for reversed. Now basically we're going to have two of these VRs themselves in a V. So just to start off with though, I want to just get this VR done so that I can make that, copy it over, and then figure out exactly how I'm going to put it in a V formation. Now after I made that, I tried to rotate it a little bit, but I forgot rotating things in Besiege is sometimes a little weird, and for some reason it didn't center properly. So it wasn't the biggest deal. I just had to delete what I had and then recreate it horizontally instead of vertically. And after I got that done, still rotates freely, and now I'm ready to start putting on the pistons. So for that, I just used a couple wooden blocks to build up a bit, and I threw a couple hinges on there too, and the hinges are going to allow the pistons to swing side to side as they go through their full rotation. So then I also put on those pistons, and then finally I just set their keybinds properly. And after doing that, I realized there's a bit of a problem with my design that I really should have saw earlier. So the pistons are expanding and trying to rotate the crankshaft, and that's all good, but the pistons are also interacting with the other side of the crank, as you can see here, and they end up hitting it and binding up. So really what this means is I can't have the VR setup be as compact as this, because if I had them on the same crank, it's not going to be able to fully rotate. So after I realized this setup just wasn't going to work, I moved one of the pistons over to the other side, and then deleted the rest of the crank. And now you can see as I expand the piston, I'm able to rotate the crankshaft a little bit, and this is because both of the pistons are starting contracted, which means that they're going to need to be perfectly parallel with the crankshaft in order to get uniform movement out of it when they expand and contract. So what I do is just delete the pistons from before, and create another set, and then just rotate it 45 degrees so that it's going to be parallel with the crankshaft. And then finally, I just have to brace it to the crankshaft so that it'll stay attached to it. And after I get that, I get a little bit of movement out of it, so I decided to start working on the R part of the VR. So basically all I have here is just another crank that is 180 degrees out of phase with the first crank. And if I give it a quick test here, it all seems to sort of hold together. The crankshaft seems to be a little weak, but that shouldn't be a problem in the future. And this is where my idea of using only two piston blocks for each of the pistons is a little bit of a problem. So having two piston blocks means I'm allowed to have three different initial states. I can have both of the pistons contracted, one of the pistons contracted, or I can have both of them contracted. And because of this, that means I can only have pistons at 4 different angles. I can either have them 0 degrees, 90 degrees, 180 degrees, or 720 degrees out of phase with the initial piston. So this is a little limiting, and it makes the VR setup a little bit weird. So normally these two pistons should be like basically right next to each other, but because I only have two pistons and I have so few angles to choose from, they end up being really far apart from each other. So I really didn't like that, because while it did function kind of like how it was supposed to, it just isn't like it is in real life. So I pressed on though, and I just wanted to see if I could get this anywhere near where it needed to be. And I copied over that VR setup that I created, so now I have my two VRs, and I put them in a kind of V formation. So I just had to brace together the crankshaft a little bit, and after doing that, if I expand the pistons correctly by just toggling them right on my keyboard, I get that sort of rotation, which is honestly not very good. It's very intermittent. So I set those VRs up in a VR formation like this, and now it looks more like a radial engine than it does anything else, so I really wasn't liking where this was going. But finally, I just decided to extend this out to 8 pistons, honestly just for fun more than anything else, see what would happen. And then I just braced the crankshaft together to hopefully give it a little bit more rigidity. But that problem we saw from before, the crankshaft seemed like it was very weak, really seems to manifest itself here. And now this is, interesting. So I decided to delete what I had and sort of start over. Basically, I just wanted to re-engineer my VR setup so that it was more true to life. And to do that, I'm starting off by rotating one of these pistons like this, so that the 2 pistons are closer together. So I did that, and I also decided to brace the other side of the crankshaft, just to keep it a bit more rigid. And now if I give it a quick test, it sort of works, but it definitely has a lot of problems. So it clearly wants to rotate, it just can't quite get there. And part of its problem is just that the pistons are expanding at the wrong time, and it's sort of fighting the first piston. So to hopefully fix this a bit more, I want to add in 4 pistons so that I can give a bit more finer control of when pistons are expanding and contracting. So I pushed out the crank a bit more and set both the pistons on the second crank to be expanded initially, and this seemed to improve motion a little bit, but it's not totally perfect, and I can get it much closer where it needs to be. So if I just move these hinges and pin blocks up and out even more, and I can add in another piston like this, now as I try to run it, it seems to improve again, but I think the only reason this is better is because now I have 3 pistons and it's a little bit stronger than the first piston, so it sort of, I guess, wins the fight a bit more, and I can sort of just overpower the first piston. So it didn't really fix the problem as much as it just sort of hid it away. So I finally added in that 4th piston, and again, things seem to be better, but I think it's that sort of unintentional fix, because now what I'm going to do is expand the crank a bit more and make it 2 units instead of just 1. Now this means that the diameter of the crank is going to be 4 units, which matches perfectly the pistons. Since I have 4 pistons, they'll expand a total of 4 units more from their fully contracted distance. Now this matching means that the piston should give me a full circular rotation and it shouldn't have to bind up or have any problems during that rotation. So after I got that done, now I wanted to sort of fix my problem here, and what I realized I could do is start one of the 4 pistons contracted instead of expanded. And this honestly seemed to be worse at first here, but I had realized I need to make sure I have the angle between the first piston and the second piston pretty much set perfectly, or else the pistons aren't going to quite line up properly, and at some point in the rotation, a piston is going to be forced to be compressed when it's trying to expand. And these internal forces are going to add up and really detract from the amount of power I can output with this engine. So getting this perfect is pretty important to get the maximum amount of power out of it. So I started drawing something up in paint here to figure out exactly what sort of angle I was going to need, and it ended up being like about 15.5 degrees. So I set them apart to about there, and after I give it another test, it seems to be having some problems. But what I also decided to do was add in 2 more pistons to the first crank, and after doing that, I can actually get it to rotate pretty regularly. So basically I'm back to where I was before, but except this time I feel like it's much closer to real life, and I don't feel like I'm cheating. So now that I had that first VR setup working, I wanted to add in a second one. Now, I didn't want to just do a straight up mirror copy of the first one. While it would give me overall twice the strength, there would still be some dead spots in the rotation where I have much less power than other spots. So ideally, I'd want to set these pistons up to be slightly out of phase so I can give myself a bit more continuous rotation. So I copy over one of the stacks of pistons, and I do end up mirroring it, but I end up rearranging the pistons a little bit so that I can put it on this crank instead. And you'll also notice this crank is vertical, while the other 2 were horizontal. So if I give it a quick test now, as I try to expand and contract the pistons, I can sort of start rotating this crank. It's also disconnected from the first crankshaft at the moment. I decided to do this just because it's easier while I'm testing. So I got that all in place, and now I wanted to add in that second crank that needs to be 180 degrees out of phase to complete that VR setup. So I did all that and then braced it together. And now if I give it a quick run, it all seems to be holding together, which is usually a good sign. And then finally, I just copied over that second piston I had from before, and I just had to flip it, and just need to get it into position to attach to that bottom crank. So I have to do that, and then rotate the swivel joints to face towards the pistons. I just braced it to the crankshaft, and decided to give it a quick run. And it wasn't perfect, because there's still a lot of dead spots, but it was able to rotate all the way around. So now I'm going for the part that makes it look more like real life. So now this step is a little bit unnecessary. I'm rotating the 2 cranks in closer towards each other, so it looks a little bit more like it did in that picture, and it looks a little bit more like that W. So this also has the effect of putting all the cranks in the same plane of each other. You can see these cranks and these cranks actually look identical. But that's okay, because the pistons are still out of phase of each other. The rotation of these cranks actually doesn't matter as long as the pistons rotate with them. So I just get the 2 cranks close to each other, and then finally brace them together so that these 4 sets of pistons are all working together now. And the movement on this is much more fluid than before. It's still not perfect, there's still a lot of dead spots, and for that I'm actually going to make another set of these 4. That's going to be later in the video though. For now I want to start getting this thing to be automated, since it was actually working out pretty well. So my first thought was just something very similar to what I did in my first engine. That's having spokes of different lengths on the output of the engine to be able to figure out out what stage I should be in. Now, what I mean by stage is since I have 4 pistons that make up each large piston, each of these pistons is going to need to expand once and contract once to be able to complete a full cycle. So that means overall I'm going to have 8 unique states I need to deal with. So to start off with something simple though, I start off with just 4 spokes since that's easier. And I really didn't know where I was going with this initially. I just set up 2 sensors looking at these spokes, and you can see the lights are flashing on top. So they are detecting when spokes are in front of them and when they aren't. But again, this wasn't really helpful. I didn't entirely know what I was doing with this. So I put down 4 logic gates, and I just set the first logic gate to be a logical AND between the 2 sensors. So when both of those 2 sensors are blocked, it'll turn on. But again, this wasn't particularly useful. I didn't really know what I was doing. I was sort of just messing around, but it was in this that I ended up figuring out what I needed to do. So as I said before, each piston's gonna need to expand once and contract once in the cycle. So that means I need 8 unique states. So I realized what that meant is I was gonna need 8 spokes to be able to denote each of these 8 states. So I copied over those spokes and put them on the same swivel joint from before, but they ended up deforming a little bit because the swivel joint only has 4 attachment points. So putting stuff in between them makes it sort of just deform weirdly. So what I ended up doing is just putting those 4 spokes onto a wooden block, and then attaching that wooden block to the crankshaft along with that swivel joint. And after doing this, everything seemed to be pretty rigid. So it had occurred to me at this point, I could actually just use a single sensor to make this work. So basically if I have just one sensor and I count out each time it sees a spoke in front of it, I could figure out what state I'm in. So I used a few logic gates down here, put them in toggle mode and cascaded them into each other. And then what this creates is just a simple binary counter like this. And by decoding what state it's currently in, you can figure out what pistons need to be expanded and contracted at any given time. So I'll need some way to be able to count out these 8 unique states. And that's where I have those logic gates in for. So I actually deleted that 4th logic gate since I can count 8 unique states with just 3 gates, so the last one is actually unnecessary. And then finally, before I make that decoding circuitry, an important thing to do is just to have inverted outputs ready to go. So now I have 3 other gates that are just inverting the gates above them, and this will just make it easier for decoding. So for that decoding, I'm going to need 8 logic gates, and this is for each of those 8 states. So I put those in place, and also I put in another row of logic gates. Don't actually end up using them because I run into another problem first. And you can see as soon as they load in, this logic gate ends up lighting up, which means it's correctly detecting it should be in the first state. But I realized also that the logic gates were making that wooden beam sort of swing up and down a lot, so I pinned it in place, but quickly realized these logic gates did not like to be close to each other and ended up just vibrating a lot. So to fix that, what I did is just staggered the gates like this, but it also occurred to me at the time I could simplify my design quite a bit because in reality I actually only need 2 logic gates counting what state I'm in. Now this actually is less than the 8 unique states I'm going to be counting out, but I could sort of have a little bit of a hack here. Basically, the first 4 strokes I need to expand or contract pistons in a specific way, but on the backstroke I can just undo that in the exact same order. So if in the beginning I expanded pistons 1 and 2, and then contracted 3 and 4, I could do the opposite, and contract pistons 1 and 2, and then expand 3 and 4. So I could just do the exact opposite of what I did in the beginning. And to get this to work, I can just set up a bunch of toggle gates. Now the effect that this is going to create is that the first gate should turn on, the second one should turn on, the third one should turn on, the fourth one should turn on, and then it should do the opposite. When I went to test this, I had a few issues, like here, gates seem to be just randomly turning on whenever they want. And at the time, I didn't exactly know what was happening. In retrospect, I do know the decoding circuitry was working of decoding what state I'm currently in, but it's just not storing that state properly. So what I did is separate out the decoding circuitry from the data storage. And really just by doing this, I wanted to verify that the decoding was working properly. I also decided to put the sensor on a piston like this. And what this lets me do is slide in the piston so that it's able to see those spokes at the right time so that I could start the engine whenever I'm ready. This just makes it a bit easier in testing where I get kind of a large lag spike almost immediately as soon as I load in since I have so much going on here. But after I do that and give it another test here, you can see the decoding is working properly. The last gate turns on, the third gate turns on, the second one turns on, and finally the first gate turns on. It's backwards, but it's actually not a big deal. But the bigger problem is that it's not turning on the gates properly. It's not giving me that cascading effect that I'm looking for. It's just really just seemingly randomly turning them on. And I tried a few things to fix this. One I thought was buffering the inputs, since my counter circuit does introduce a little bit of weird delay. So I added in these extra 2 gates here, but that didn't seem to fix my problem. If anything, it just seemed to complicate it even more. But it was in this, I started just staring at these gates longer and longer and realized my problem was that I had gates turning on when they're not supposed to for just fractions of a second. So what I did is added in a few timer blocks, and what these are doing is just rejecting really quick signals. So I put those in place and then forced them to have a 0.1 second delay. So only if the signal inputted to them is longer than 0.1 seconds, which means it has to be a valid signal, will it get passed through to the data storage. And after doing that, it actually basically just started working. The engine is working totally on its own right now. I'm not pressing any keys to make this work. And you can see that cascading effect here. So the first gate, second gate, third gate, then fourth gate turns on, and then the first, second, third, then fourth turns off in that order. So now with that looking pretty good, I wanted to add in 4 more pistons like this, and this is just going to increase its stability during its rotation. So just doing a straight up copy like this doesn't make it any more stable. It does make it a bit stronger at times though, but there are still some dead spots. But even so, the engine still seems to rotate more regularly, which is a pretty good sign. So finally, I just deleted all the crank and piston components like this, and then finally started putting in a new set of cranks. So after getting those in place, it was time to start putting in the pistons, and I started with the easiest one, which was this. All the pistons start out extended, and then I just need to brace it to the crankshaft like this. So it's the quickest one to get in place, and the next 3 I thought were going to be about equally as hard, so I just randomly picked one. And for this one, what I ended up needing is 2 of the pistons to start out extended, and then 2 of them start out contracted. So after putting those in place, I just rotated the pistons down towards the crank, and then braced it to the crank. And if I give it a quick run here, all seems to sort of work out. This second part of the crankshaft isn't braced very well to the first part, so the movement's still not totally set right, but I'll fix that in a little bit. So this third crank, what I need to do is just have 1 set of pistons be extended and the other 3 not be extended. And then finally just gotta brace that to the crankshaft. And then I have this last piston to do, and I thought it was gonna be pretty easy, but it ended up being a little bit harder than expected. So because I didn't set all the angles perfectly while I was making this piston ended up being inside the hitbox for the swivel joint. So to fix that, I just needed to nudge it up a little bit like this. And after getting all those pistons contracted where I need them, I just braced it to the crankshaft like this. And then finally, I was super close to getting this to work. I just had to set all the keybinds on these pistons where they needed to be, so that they expand or contract with the correct stage. And now finally, I have those 4 pistons working. So as I said before, the 2 crankshafts are working fairly independently from each other. So I braced them together, and also copied my entire engine, and this is going to double the strength of the engine. So now I have a total of 16 pistons. I mean, I have technically 128 piston blocks, but I have 16 piston segments. So my game's extremely laggy now. I guess it doesn't like all the pistons plus the car running in the background, but the engine seems to work pretty well on its own. And in fact, the movement seems to be much more fluid than the inline-4 engine that I have on the car right now. And in fact, speaking of that, I want to do a head-to-head, just basically attach these engines directly towards each other and see which one wins, or if neither wins. So I put a couple gears on the engines, meshed the gears together, and then connected the gears to the outputs of their engines. And now finally, I just disconnected the gears from each other to make sure that the engines were going to be rotating separately from each other. And I realized here I actually did mess it up. They were rotating in the same direction. So if I put them head to head, they were going to be helping each other instead of hurting each other. So I just flipped the direction that the inline engine was running. And then finally, I connected back up that gear and gave it the test. So it might not be so obvious what's happening here, but the big engine is actually rotating the inline engine in the opposite direction. It's literally rotating it in reverse right now. So clearly this big engine has a lot more power. I mean, I would hope so, since the small engine has 16 piston blocks and this big engine is 128. So I would hope it's much more powerful. But it's at least a good sign that I did make something that was better. And so I sort of just went crazy and attached this onto this car. This literally took me probably an hour of just bracing stuff and getting everything ready to go. But after I finally got it put in place, I decided to give it a quick run here. And I also sped it up just a little bit. I'm getting literally like 15 FPS and it's kind of painful to look at. So that's why I sped up the footage a little bit more. And the car is still able to move. Now, if you watched my transmission video, you'll know a big issue I had was gears that were skipping. And that's actually the main issue I have here. The engine is well powerful enough to make this car move faster, but the transmission just isn't strong enough. I didn't make it for an engine that was this strong. I made it for the inline engine, so it's tuned for that. So that just means that this engine is more powerful than the transmission can really take on. I'd have to come back and revisit that if I wanted to use this engine. But even so, this engine is so laggy. If I actually want to turn on shadows and make it look kind of good, I get like 8 frames per second, and that's just too little for me to realistically want to use this engine more. So guys, thanks for watching, thanks for 100,000 subscribers. This video ended up being harder than I thought to make because this engine was just more complex than I really realized it was going to be. I still think it turned out pretty well though, and overall I'm happy with the result. So if you have any questions or comments, feel free to ask below, and otherwise, until next time.